So, today I will talk about a new technology, what we developed together with a machine manufacturer in Germany called Rulermat, and it's about a new technology, how to produce durable dual interface cards. So first of all, I would introduce Smartrac a little bit for the few people who do not know Smartrac yet. And then I will talk a little bit about the current production or the main production technologies for dual interface cards. And then we go to the HERA process, how this is defined, how the process flow is. Some commercial and technical key data of this HERA process, this HERA machine, and some pictures, 3D models of the machine itself, and as well of the HERA card, how a ready-made HERA card looks like. So about Smartrac. So Smartrac is a supplier of RFID transponders. So the inlays means prelamps, inlays, so not ready-made cards or ready-made labels. So we are doing all the pre-products, means combining the chips plus combining the antennas to the ready-made pre-product, which could be processed into cards or labels. Smartrac was founded in 2000. We are Dutch NV, so means the holding is in Netherlands. Management board is Dr. Fischer, maybe well-known Wolfgang Schneider, and Robert Hermansen. The sales, what we did in last year was 168 million euro, with the EBITDA of around 15 million euro in the whole group. The number of employees which we have worldwide on all our different production and sales locations is about 4,000 people. So we try to keep the leadership with quite a lot of patents, with quite a strong R&D team, what we have in our different locations. So we currently keep about 370 patents and patent applications. We have quite large production sites for all different frequency, means low frequency, 125 kilohertz, 13.5 megahertz, as well as UHF. In the whole RFID industry. So end of last year, over the whole last 12 years, we produced more than 2 billion RFID transponders, so there is some experience behind. Here you see our global footprint, so that means we are on all parts of the world. You see the different production sites as well as partners from us where we have a stake in, as well as sales locations. So the main production sites what we have are in Asia. Main production site itself is in Thailand, but then we have some local production sites depending on the products, depending on the applications, also in Americas, as well in Brazil and in Europe. So, but now let's come to production technologies for dual interface cards. So the most used production process as it is of today is the conventional production process for dual interface cards is a gluing process. So that means where you glue the dual interface module electrically on the antenna in the card body. So there are different names in the market, like from Mühlbauer Flexband process, other soldering or gluing processes. But these processes are less reliable. If we talk especially about cards for the ID sector, where you talk about reliability or lifetimes of 5 to 10 years, which are expected. So this technology might be good for cards with a usage of 3 years, but not more. Or the other way is that you need some manual processes involved into that if you want to have a more reliable card with soldering processes. So that means manually hand soldering of the antenna to the dual interface module. So therefore we thought about to find a way how to automate a process which really gives a reliable solution for dual interface cards. Therefore, we come to our production technology, which we name DDI, stands for Durable Dual Interface. So this is a process where we really have a metal-to-metal connection between the antenna and the module at the end. So we go for 2 ways on that. So on the one hand, we have a so-called DDI Prelim. So that's a special prelim where we already integrate the module into the prelim sheet. So that means the card manufacturer in this way has not to integrate the dual interface module itself, as it's already integrated, so he directly can go on for the card lamination. And then we have the main topic of today, which is the HERA process to produce dual interface cards in a fully automated way. So, but a few words as well for these DDI prelim, what we offer. So here you see a prelim where we directly, with the mic. Hello? Yeah. Prelim where we directly integrate the module in the prelim sheet. But for sure, we cannot integrate the module on the same level as the prelim itself, as you need, or the card manufacturer need to add the print and the overlay sheet. So there is some gap between the surface of the prelim and the surface of the module. So in this gap, at the end, will be filled with the print sheet and with the overlay sheet. So, which needs to be punched before the lamination process. And this, at the end, gives the final card. Here you see the print or the overlay sheet with the punch out for the module. The connection between the module and the antenna is done in a solid way with TC interconnection, so thermal compression, the same as we do for the full contactless cards as well. So that means that gives a reliable connection and a reliable card, also with a lifetime of 5 to 10 years, which could be achieved with that. So this also technology which is available for different materials, means PVC, polycarbonate, as well as PETG. So for the HERA process itself, let's start with the process flow. We start with an inlay. So an inlay where you have the wire embedded antenna with some copper or with some tin pads for the connection. So this is directly supplied by Smartrac, so no influence on the card manufacturer here. The second step will be the setup of the card body at the card manufacturer. So this is the same like for any other full contactless card, where you simply integrate the inlay into the card body. So that means on the inlay you add the print sheet, the overlay sheet, lamination, punching, then the card body is done. Next step will be the milling. So for the milling, you do the milling of the cavity for the module, as well as you do a special milling for the connection pad. So here you need the so-called sensor milling head, which detects the copper pad or the tin pad, so that it stops the milling process after it has touched these areas. So then you have the cavity where later on the module will come in, as well as the cavity area where the connection will happen. So this is the card body which then will spend into the HERA process, so into the HERA machine. So the next step is that in the HERA machine, fully automatically, there is a connection of straps. So we don't use a wire. I will tell you later why. We use a special strap which will be connected to the antenna connection pads. Then in the next step, the other end of the two straps will be fully automatically connected to the connection pads of the dual interface module. And then, after the connection was done, then a first test could be achieved. So that means even before you glue in the module, you can make a full electrical test of the card. If the card works, if the antenna works, the RF interface works. So that means in this case, you even could take out the card of the production machine to rescue the card body or the module. So this definitely makes sense if you're talking about highly expensive dual interface modules, which could cost up to €2. Then it for sure makes sense to rescue the module if there is any problem with the connection or the antenna before you glue it in. So for the process flow itself, so we said the inlay comes from Smartrac in this case, inlay manufacturing. Then you go with the artwork printing and the overlay preparation at the card manufactory for the card body manufacturing, where you do the collation, the lamination, the die cutting, and the special cavity milling. Then you need to have a module preparation in this case. So the module preparation means you need to add hot melt, the same as you do anyhow for a contact module or dual interface module. So no special other preparation of the module required here. All the further preparation of the module will be done in the HERA machine, in the HERA process itself. So for the HERA process, then you spend in the card bodies and the modules still on reel. Then the modules, there will be a solder application so that you put solder material on the connection pads of the dual interface modules. So and then the HERA machine combines the card body as well as the module in the shown way as I showed you before in the process flow. Then at the end, you can do, for sure, full testing in the machine itself, and you also have the possibility with an additional module that you even do a pre-personalization or even a final customized personalization of the cards. So, some key figures. As mentioned, we as Smartrac, as we are not a machine manufacturer, we do this in a cooperation with German machine manufacturer Rulamat. So we own the design and the patent of this. So this is done as Smartrac do not offer any after-sale service or any spare part supply. That's what we cannot offer and will not offer. So we as Smartrac will not go into the area of machine selling. So we as Smartrac are interested in selling the inlays later on for this process. So therefore we involved Rulamat in this game. So the minimum UPH is about 1,200 cards per hour. We even try to bring it up to 1,500 cards per hour, and this is based on a so-called Pearl platform from Rulamat. So also here we try to bring in as much as possible already existing modules from Rulamat into this process so that we do not have to develop every single step of the machine by ourselves. Very important for this process is the target module lead. It's 99.7%. So, which is also very important if you talk about highly expensive dual interface controller modules. Could cost you 1 to 2 euros. Therefore, every card counts. Target machine availability 90%. The full card test before module embedding possible, as just mentioned, so there still would be the possibility to rescue the module or the card body before embedding. There is even the possibility of an optional integration of different card tests and card precursor modules in the line, as it is a flexible module concept. And furthermore, it's also possible to integrate the milling module so that you do spend in the HERA process not the already milled cards, but the pure card body without any milling, so that the milling process is done as well in the HERA machine. So here you see a bit about the process. So it's a round table concept, what we do.
Please can you make your way to seminar theatre number 3? Thank you.
No, please stay here. Don't go to 2 or 3. So it's a roundtable concept, so that means where the card is spent in, the module is spent in. So here you see the feeder for the module. So the module is brought in, then here the card body is brought in. And then step by step you do the tinning, so where you put the tin on the module, as well as you spend in the wires and do the connections, as well as the special folding, which I will show you in some samples of the wire, and also the gluing process will happen on this round table. So the standard module, so that means this is the special HERA module, what is brought in. All the other modules which you see here are standard modules, which are used from Ruler-Mat for other machines as well. So where you bring in the card body, test station of the antenna, if there is the antenna in, if the milling was done in the correct way. And then here the gluing, the hot and the cold station for the gluing process for the module. And here the test and personalization stations. So the machine itself looks like this. So also here the standard modules for bringing the card, test the card body. Here in the center the round table concept for the HERA production, for the HERA process itself, as well as the test station at the end. So in here you see there are different modules which you can add additionally milling modules in this area as well if required, so that you can spend in unmilled cards. So once again the open machine with the round table concept again. So here's some pictures of the open card with the module not glued in yet. So here you see the special tin pad which is used on the inlay already. The connection between the antenna and the module made by a special strap what we use here. Here you see the connection made to the module. So in here you see the special folding what we do with this module. So it's we call it a sigma folding of the strap. So this gives some spring effect at the end, and with this spring effect you also have some additional connection between the antenna and the module. So even if the card is bended or the module is bended, or even if the module will come out of the cavity, you still would keep the electrical connection. So in here you also see why we use a strap and why we do not use a wire, because only with such a strap what we use here, you can have the special sigma folding. So if you would use a wire also could fold in this direction, so at the end comes out of the card body and is beside here after you embed the module. But with this special strap and the sigma folding, you can ensure that the strap at the end is always inside this cavity later on when you embed the module and glue the module in. So that's how the card looks like at the end, or the connection between the module and the antenna. Yeah, for more info, come to our booth 37C, which is down there. I also have some sample cards which you can see. That's it from my end. So thank you very much for your attention. Any questions?
Hello.
Hello.
First, concerning the rate of production of the machine, you mentioned 1200 was targeted to 1500.
Yes.
This is for which steps of the process? Is it including pre-personalization or not? I mean, which stages are covered through this amount of cards?
This 1,200 to 1,500 cards per hour is for the pure production process of the card without precursor, because for the precursor it depends on the amount of data you want to write on. As you might know, it could take up to 30 seconds to do a full personalization of a controller card. So that is not included. So it's the pure mechanical production process of the card. What the HERA process is able, so this roundtable concept is able to do.
Okay, second question about the idea of checking the card before implanting the chip.
Yes.
Is this done by a separate module of the machine?
No, this is integrated in the roundtable concept. So the last step before the card or the module will be glued in is an electrical test on the roundtable, and if this test fails, the card is sorted out.
Okay.
So you get in a separate station this card, and for sure then you can decide what to do with the card. But at the end you get a card without the glued-in module, because to get out a glued-in module out of the dual interface card, that's hard to do later on.
Yeah. So this is electrical testing.
That's electrical testing
on the round table.
On the round table before you spend it to the gluing station.
Okay. Thank you.
You're welcome. All clear? Any further questions? Okay, then thank you very much for your attention.